welcome to today's session, Closing the Kubernetes Cost Loop with GitOps. Just to cover a little bit of housekeeping, I just wanted to let you all know we will be recording today's session, so we'll send an email of that recording out to you probably within the next day or two. And on your console, you'll also find a PDF version of today's presentation, so feel free to download it and follow along. There's also a resource slide at the end that has a bunch of links to different things we'll be covering today, so you'll want to make sure that you have that for later. And then there's also a Q&A feature on your console, so if you have any questions throughout, feel free to just submit them there, and we will cover as many as we can at the end. So moving on to the agenda here. So we'll start with just some quick introductions, and then we're going to talk about why this topic matters and why GitOps is a useful model for operationalizing your Kubernetes optimization. From there, we're gonna kind of go into the core building blocks of what you'll need for the example we'll walk through today, which is recommendations from Kubecost, and then also Argo CD to kind of automate your workflow in your GitOps. From there, we're going to go through a high-level example to show you how all these pieces work together, and then we'll end with some kind of closing thoughts and best practices. So moving on to our speakers. Our first speaker is Joe Dahlquist. He is our head of product marketing here for both IBM Kubecost and IBM Cloudability. He has experience, across lots of different industries like cybersecurity, cloud, fintech, edtech. If you'd like to connect with him, you can find a link to his LinkedIn there. And then our second speaker today is Nate Andrews. He's a senior solutions engineer here at IBM Kubecost, and he helps all of our customers from discovery to adoption, and leading POCs and helping with getting customers onboarded. He also has experience across several different industries like DevOps, AI, enterprise technology, and expertise spanning public cloud, MLOps, and big data. So he'll be leading the live demo portion of today, and he also is the author of the GitHub repo that we'll share with you that has the example that he's going to be walking through. So if you have any questions, you're also welcome to connect with him on LinkedIn. And from there, I will pass it off to Joe.
Thanks, Dee. Welcome, everybody, and thanks for joining us today. I hope we're going to show you something interesting, something you might be able to put into action yourselves, really cool automation capabilities that we'll be discussing and demoing a little bit later. If you're not familiar with IBM Kubecost, let me catch you up. We are a real-time engineering-grade cost visibility and optimization solution for teams that are working with containers. We help teams continuously understand and reduce their costs of operating Kubernetes while balancing performance. Our solution runs on any Kubernetes environment, AKS, EKS, GKE, custom flavors, unique environments are all covered by IBM Kubecost. We have a great catalog of customers that we appreciate that includes some of these large names from GitLab to Audi, Johnson & Johnson, and others. And on their behalf, we're managing more than $5 billion of their spend in container environments. And we're a global organization, so wherever you are in the world, we have experts standing by ready to help you explore these tools, implement these tools, and see if they solve the challenges that you're working with. With that, we'll go ahead and jump on in. So Kubernetes optimization is not a one and done thing. It's not something that you should be doing once a quarter, once every 2 months, on a weekly basis. This is something that you need to continuously stay on top of. Requests and limits are usually set from a point in time snapshot, when something is being constructed, when you're ready to start operating it. But those workload conditions can change dramatically after you've deployed, especially things like traffic patterns or application behavior, or the teams that might have ownership of those resources and those workloads that you're operating. Those changes can make things that were previously the right limits, the right resource settings, pretty inaccurate over time. And with that inaccuracy comes the risk of both performance issues, but even more easily, sneaky ways of having that bill and that spend creep up because you're not utilizing the resources that you're reserving. Resource drift also can have real consequences. whether it's over provisioning that can waste a bunch of money and keep you from having funding for another cool project, or under provisioning that can really impact performance, stability, resiliency of your applications as well. These static resource settings can age pretty quickly. What seemed to be the correct limits, the correct resource requests at the onset might become incredibly aged and incorrect in a pretty short period of time. Things are very dynamic when it comes to Kubernetes. Short-lived containers can really start to mount up if you're not paying attention to those resource limits. What teams need to solve some of these challenges is a safe and easily repeatable way to turn these changing costs in this dynamic environment into actions that they can take to safely reduce cost and optimize resources without negatively impacting the performance of applications or their resiliency. The real challenge here isn't finding recommendations. Those can come pretty easily. It's applying them safely in production. Making ad hoc changes like manual edits can introduce a lot of risk. Whether it's an inability for the team to review and approve those, or to understand who made a change and when and why, these things can lead to drift, and drift can become a real problem in your environment. GitOps is a really safe operating model for applying these organizational changes in a way that is easily understood, easily trackable, adheres to all of the good hygiene that we have about reviewing and approving PRs. Governed GitOps enables things like code-based changes or pre-deployment review, to be able to understand what the Git history is of a particular feature, capability, branch, or code change. And it allows you to repeatably and safely roll out those changes and deployments in a way that has a lot of observability capability. GitOps isn't just deployment automation. It really is a control mechanism that helps you implement operational changes. One of the things that Kubecost is incredibly good at is identifying savings opportunities and finding that balance between application performance and resiliency and cost optimization. So we're doing it in kind of a performance-aware manner where the recommended changes that Kubecost is going to surface for you are largely going to be safe for you to implement right away. So how do you go and take that next step? In this workflow that we're going to be discussing today and showing, Kubecost is like the origination source for these optimization signals, these cost savings opportunities. So Kubecost is surfacing these opportunities, but it does more than just show like what that spend is. It doesn't, keep you from understanding where your optimization opportunities are. It turns that data into some actionable savings recommendations that you can go and act on right away and realize the efficiency gains from following those recommendations. What you're looking at here in the center is a set of what we call savings cards in the savings area of Kubecost. They show like useful inputs at a glance, things like the recommendation type, whether that's right-sizing node groups or container requests or managing orphaned or unclaimed volumes, abandoned workloads, things of that nature. These recommendations are going to help teams prioritize which actions to take based on the impact, not just the fact that it's possible to do it, but in a sense, showing you what you're going to gain by doing it, what your actual realized savings could be by taking the actions that have been recommended to you. Kubecost can also surface things like GPU optimization opportunities. Those are critically important for some of these more expensive AI and machine learning workloads, whether that's inferencing jobs or model training that you're doing. GPUs have become one of the largest cost sinks for organizations, partly because they're either on or they're off, and it's really difficult to optimize those to become highly efficient. They consume a lot of energy. They generate a lot of cost for the organization. And certainly GPUs don't grow on trees these days. So one of the things Kubecost can really help with is helping you increase the efficiency of your GPU utilization, and by virtue of that, the spend that you've got related to GPU workloads. In this workflow, the recommendation is going to become that input signal for a governed GitOps process to then be able to implement those savings recommendations and ensure that you can keep the benefit of those over time as this environment changes, as the teams maybe who own the workloads and the infrastructure change, and as those things grow and evolve over time.
And before I jump into the demo, just wanted to start with a quick GitOps Argo CD primer. So, for those of you that aren't familiar with GitOps or Argo CD in general, as Joe was mentioning before, the idea is, especially when you're managing many different Kubernetes clusters, your fleet is getting a little untenable where you can't automatically just go into a single cluster, deploy applications, change them in there using kubectl. We need a strategy that scales more, and GitOps was created to solve that problem. So basically the idea is we define our infrastructure, so the YAML definitions of our applications, in a Git repo. So that gives us the ability to basically give us all the features and source control for our applications that we can get now for our infrastructure. So that gives us much better scalability and the ability to roll back and just track changes in general and use it as a source of truth for how we want our infrastructure and our applications to be defined. And then basically what the workflow looks like is we'll deploy our YAML definitions into a Git repo, and Argo CD acts as basically the gatekeeper, where it will basically look at this Git repo, look at the cluster, and make sure that those are both matching. And then we give Argo the permission to say, like, hey, if someone goes in and manually changes something on a cluster, it has the permission to roll it back. So we know that Argo is keeping everything the way we intend it to be, the way we define it in our repository. So it's that constant reconciliation cycle between Argo CD and the repo, and being able to assure that if we want a single application or deployment running across all our clusters, that Argo is going to make sure that it stays that way, and someone accidentally or maliciously can't go in and make manual changes after the fact. So walking through the demo today, we're going to be combining a couple different ideas. So we're going to be combining the idea of basically using GitOps, and then also combining the idea of, how do we take the data that Kubecost is giving us in the UI and using the Kubecost API to basically make some automation scripts where we can bake that into our existing GitOps pipeline. So typically, where this kind of came from is, I've talked to a number of customers that really love the data that Kubecost gives us, loves the right sizing recommendations, but they don't like the idea of, an agent or something like that just making these recommendation changes in their cluster without any human in the loop. That can introduce a lot of different problems, especially with AI now. Sometimes there's unintended consequences for just letting a script or an agent kind of work uninterrupted without any human controlling things. So we basically use Kubecost data, and then we use the Kubecost API to basically create a script, an automation script, where we can call the API, update any YAML manifests in our Git repo, and then create a GitHub pull request where we have everything that our normal GitOps workflow gives us: security, human in the loop to review changes before we apply them. So this removes a lot of the friction of developers typically don't like to use UIs in general. So there's no need to go into the UI of Kubecost, look at the recommendations, and manually apply them or manually update them in our Git repo. We can just have this script running, and then all we need to do is go and look at the pull requests and either approve or deny them for various reasons. And then once we do that, Argo does its thing, and it will apply any changes or any right sizing recommendations that Kubecost gives us. And then we can start saving money, and we know that any right sizing change that Kubecost gives us and we apply, we know that a human engineer checked it, and we're good to go. All right, so let me share my screen and we'll hop into a quick demo of what this looks like. Okay, so just starting out, let me zoom in a little bit here so everyone can see. For those familiar with GitOps and Argo CD in general, a lot of this is probably pretty familiar to you, but for those that aren't, as I was mentioning before with this GitOps workflow, we basically define our Kubernetes manifests in a Git repo. So here I have an example deployment, and we just have a YAML file that just shows, we want an Nginx deployment, and we have certain CPU and memory requests that we defined here. And then we basically just manage this, and this just sits here for Argo to read from and deploy to our cluster. And then if we hop over to Argo, we can see what this looks like in Argo. So basically, Argo has the concept of applications, and then basically we just tell Argo, hey, look at this Git repo that I set up for it, and then we look at a certain path or a certain target revision. And then, Argo will look at basically all the YAML in this repo and then apply it to the cluster without us needing to do anything manually. So if I need to make an update to this deployment, change a replica, or change a sizing, I can make the change in my IDE, push it to the repo, and then Argo is just going to constantly sync in, and then we can see that right now it's deploying the 3 pods that I've set in my deployment. Everything looks healthy, so we can tell that Argo is making sure that everything's in sync, and if it notices something that isn't in sync, it'll do its best to reconcile that. So with this deployment running, what we can do is, since we use Kubecost, we can see what right sizing recommendations Kubecost is giving us for this workload. So we can filter within Kubecost. So because we're scraping from the Kubernetes API, anything we define in YAML, we can filter by to look for our specific workload. So I know this namespace is in webinar tests, so let me apply that. And we can see that Kubecost is giving us some right sizing recommendations. So we can see, I've defined way too much memory and way too much CPU for this deployment. And then we can even edit these recommendations as well. So right now we're just looking at the past 3 days. If we want to go farther back in time, we can do so. Usually with recommendations in general, the more runtime you have, the more accurate these recommendations are going to be. So we can take into account all those peaks and valleys of traffic. And then we can also customize our recommendation profile. So right now I'm doing production, which is just giving it about 35% overhead on max utilization of CPU and memory. I can edit this if I want to. So if I want a little bit more headroom, we can go to high availability and get 50%. Or if we want to customize this, we can create a custom one as well. So if I needed, a little bit less CPU and I want to be safer with RAM, I can do so, and then it'll regenerate these recommendations for us. So, that's all well and good. But as I was mentioning before, we want to create a more seamless workflow, right? We want to be able to get this data into our Git repo without as much friction points of me needing to go in here, manually noting these down, and then applying them in my repo. We want to find ways where, hey, can we automate this as safely as possible? And with that, we can do that because of, all the data I'm showing is retrieved from the Kubecost API. So I can show what an example of that looks like. So let me bring up my terminal here. And then, so if we want to do an example and get the data that we were just seeing in the UI, we can just do a curl command to the Kubecost endpoint. And we can see we can edit this much like we can in the UI. So we want max utilization here, and we're looking at about 65%. So we want about 35% overhead. In the window, we want to do 3 days. And then we're just looking at my specific workload. So if we put this in, we can see an example return that looks very similar to the UI. And we can see the same recommendations here of much less CPU and much less memory is needed for this workload than I have set for it right now. So we can make those changes. So if I just pop back into Chrome here, putting all these pieces together basically is, we want to be able to use this curl command, and we want to integrate it into our GitOps. So how do we do that in a more automated fashion? So that's where I created basically this Kubernetes cron job that essentially will do this manual workflow that I was just going through. It checks out the Git repo that our application is stored in, and then it will basically clone the repo locally, and then it will basically do that curl command that we're looking for. And we have some regex in here, and I'll share this Git repo after this call so you can look through the code yourself. But the idea is we want to put something in our Kubernetes cluster where on a certain in a certain time, like with a cron job every day or every week, we want it to check in with Kubecost and basically say, hey, if there's any recommendations that we see for the workloads that are in this specific repo, why don't we pull them out and then apply them and then cut a PR for it? So, I won't go through all this code here, but, I just want to point out, the idea is, we can use the tools at our disposal to create something unique to our environment. So showing the art of the possible of what we can do with just a little bit of scripting. And so just going through here, and then basically, we have that script that calls the API, and then we just define a cron job in our cluster. And this can be customized. You can fork this repo. This is a public repo, change it as you need. And then we set a schedule. And then all we need to do is basically just set some environment variables. We set which Git repo we're looking at, which branch. And then we just kind of set unique to our environment. How much overhead do we want to get for our recommendations? And then we just define an access token as a secret for our repository. So if we have a private repo, we don't need to make the repo public, and we're using security best practices within the cluster. So basically, from a Kubernetes standpoint, this is what this job looks like. And then we just apply this as a cron job within our cluster, and it'll be able to continually check in with Kubecost and then apply those changes. So let me pop over to my terminal. And we already have this running. So let me zoom in a little bit here. So I already have this deployed in a cluster as a cron job, and then we can kick off a manual test of this job and see what it gives us. So we created this, and then we can do kubectl get jobs in the Kubecost namespace, and we can see it already completed. So what we can do is we can look at the logs of this job. And we can see basically what the script was doing. So what we can see here is basically, as I was describing, it found the GitHub token for our repo, it cloned the repository locally, and then it made a curl command to the Kubecost endpoint, and then it got the recommendations that we're looking for this specific workload. And then it just does some regex to alter these YAML files. cuts a pull request and then pushes a new pull request to the repository. So that looks good. So let's check in with this repository, and we can see a pull request waiting for us, which is great. So we can check in on this pull request, and we can see that it's making some recommendations, and it's applying those recommendations that Kubecost gave us right into our YAML. So then, with a human in the loop, I can merge this. Looks good to me. And then I can merge it. And then Argo will see this, and then Argo will be able to apply this change when it does its next sync in with this repository. And as I mentioned before, I'll share this repository with you after. Feel free to fork it, make any changes, make any pull requests to it. This is more of a passion project right now, so I'm always happy to have suggestions and how we can make this more robust for customers to use. Great. So let me stop sharing.
That was great. Thank you, Nate. So we've seen some powerful automation. There's definitely some caution signs and things you should think about before you go running headlong into automating all the things. But I mean, who doesn't want to do that? Some things to think about. Start with lower risk workloads, right? Don't take massive risky leaps right out of the gate. Let's build up to those things. Make it easier to kind of learn this process without introducing unnecessary operational risks by starting small. Starting with things that do provide some value, are going to net you some savings, but aren't, flashing warning sign items where things could go terribly wrong. PR reviews, get those in early. They add an early guardrail. They help teams build with confidence. They help them move quickly, but in a safe way. It's like seatbelts in a race car. Understand what the workflow is going to do and have others look over those PRs and approve them before you start growing the number of automations that you're doing. Get that basic process under your belt and implemented and well understood by the teams that you're working with. Running on a defined cadence is also going to help keep optimization intentional instead of accidental. It's also going to prevent changes from becoming overly reactive to something that may have needed that extra headroom, may have needed that extra, those extra resources. So I would say implement these automation changes in a way that follows a regular cadence for you, your organization, the teams that you're working with. Validate the impact after you've made those changes. Look immediately, look again shortly thereafter, and then get into, again, a regular cadence of understanding whether the changes that you've implemented are good, are appropriate based on changing needs, changing environments, but confirm that you're getting the intended result with each one of these without any negative implications for the application health or resiliency. Make sure that there's clear ownership. Make sure that that owner is reviewing the changes that are being implemented. There needs to be a review and approval process and follow-up along with accountability for the whole team to make this safe and purposeful. Make sure you have the ability, and GitOps helps significantly with this, to do simple rollback paths. If you find that something isn't netting you the results that you want, or if it's cutting a little too close to the bone in terms of performance and resiliency, you should be able to roll those changes back simply without a lot of time being wasted or disruption to other teams if a recommendation isn't giving you the results that you expect. Some common pitfalls that you might run into include automating too aggressively, right? Think about those peak utilization and usage scenarios, whether it's a Black Friday or somewhere around the Christmas holidays, or every other Tuesday, or whatever the case may be. Think about where those limits really should be set for the long term, not just based on the last week or the last month of performance versus cost. Don't ignore the context of the application. Don't, attempt to necessarily right size or optimize every application in exactly the same way. These things are pretty dynamic. They're unique. You should treat them individually and implement changes individually as well. Make sure that you're applying changes that include thresholds, that include policy limits. Don't go without those things. Those are important guardrails that you need. The goal here really is to start with some guardrails, to implement those guardrails, to measure the outcome of what implementing those guardrails has done to your application in terms of cost, performance, and resiliency, and then scale that automation over time slowly as you become more comfortable with it, and you've got more and more of the team on board with what you guys are doing. If you follow some of these kind of guardrails of sorts when implementing this, you're going to have a much better time than if you just run wild into it and start breaking things. Some key takeaways here that I think are great from what Nate has presented and what we've talked about today. Kubernetes optimization is continuous. It has to be continuous because workloads and their behavior and the resources that they need to operate are going to change over time. They might not change from day to day. They may change very little from week to week. But if you look in the scope of time of how long these applications are going to live, those changes can really mount up over time. So be ready to continuously optimize based on the different needs of that application and its usage. Second thing, cost visibility is really necessary, right? Not having that visibility can lead to surprise bills, budget busting spend, things that will cause somebody to come and knock on your door and ask you why something costs as much as it does. But that visibility by itself really doesn't create value unless teams can act on it, can do something about it, and do that safely and in kind of an easily predicted manner. Third thing, Kubecost does provide the optimization signals early and accurately by identifying the savings opportunities and the right sizing recommendations that it's detected. You can trust those recommendations. You can also get a good understanding from our documentation and through use of the software itself, exactly how it's making those recommendations and what the implications of them might be. Fourth thing, Argo CD provides a good deal of deployment control. It turns these approved Git changes into a running state in the cluster and prevents drift from reverting things back to an unknown or bad state. Fifth, PR-based workflows are going to add really necessary things like governance through a review, audit, rollback, and repeatability workflow. Sixth thing to think about here, start small, or fifth thing to think about, start small, scale intentionally. As I mentioned, don't just go running wildly into this. It's the practical way to kind of build confidence. It's the practical way to get other teammates on board to adhere to a process that you implement that reduces risk and improves both the performance and the cost of your applications and the infrastructure it's on. And last, the broad message here is that cost optimization is much more effective when you connect it to some kind of governed delivery model, like GitOps, like CI/CD pipelines with policies that get enforced. This is also how you institutionalize these savings and keep the benefits of them over a long period of time, rather than being an ad hoc cost optimization activity that doesn't necessarily have the staying power and will force you to revisit optimization opportunities again and again and again. So figure out how to institutionalize these things by connecting these cost optimization insights to something that can actually govern and ensure that you've got those for the long haul. And with that, I'm going to turn it back over to Dee. Thanks so much, everyone, for attending and spending your time with us today.
Thanks, Joe. Thanks, Nate. So here's some key resources that you will probably find helpful to get started on what we covered today. If you download a copy of the PDF version of the slides that are on your console there, you can access these. So Nate has written a couple blogs that goes into more detail about how to get some of these initial Argo and Kubecost driven workflows set up. But then he also just wrote a blog. There's the second one we have linked there on how to implement some Kubecost actions with Argo CD. So those are great resources to dig into if you want to learn a bit more. And they each have a lot of the code snippets and things like that you'll want to copy and paste to leverage for those. We also included a link to Nate's GitHub repo for the example he walked through today. And then also some docs about the savings insights that Kubecost provides, as well as our savings actions and our API directory. So you have all of the resources you would need to actually get some of these things up and running. And with that, we will switch over to the Q&A here. So we did get a couple of pre-submitted questions that we'll start with, but if you have any that you just thought of or that you think of later, feel free to drop those in the chat as well. So starting with this first one, someone asked, how can recommendations be refined? For example, introducing forecasted load based on seasonality. Not sure if Joe or Nate could tackle that one.
I mean, primarily, I think one of the best things about Kubecost is it inherently kind of understands some of your seasonality based on having a long tail of data. So if you've had Kubecost up and running for those peak moments, the Black Fridays, the heavy trafficked days, the days where you've run some kind of offer special or incentive, and you've got more traffic and more utilization than in other parts of the year, Kubecost is going to understand what those peak usage points are, and is not going to make recommendations that would lead to some negative performance or application breakage when you hit those high water marks. You can also look at doing things like changing the right sizing thresholds to leave yourself more headroom as you approach those seasonality inflection points. Nate, not sure if you wanted to add anything else to that.
Yeah, so typically, what else I would recommend is, like we were talking about before, like start small, right? Do little incremental changes to make sure that, you do proper load testing and proper performance testing after every change before we just go for one big cost savings measure.
Great. The second question we received was, is using a GitOps tool like Argo necessary for automating an optimization workflow like this?
Yeah, I can take this one. So even though, all my examples are using Argo CD, you can definitely use your GitOps tool of choice. So if you want to do something like Flux, or, I know there's a lot of other ones out there, but I tried to create these examples to be as vendor neutral as possible, to just be able to work with your existing GitOps workflow.
Great. And we did have a question from the chat here. Someone asked, does Kubecost automatically scale up if resources reaching its limit without historical data?
So Kubecost will give us recommendations to, sometimes, if it's under provision, Kubecost will give us recommendations to give a pod or a resource more, more CPU, more memory, but without using anything like actions or something like that, some sort of automation on top of it, Kubecost is existing to give us information. So Kubecost won't automatically perform those actions on our behalf unless we set it up to do so.
Great. Another question we had is, can this be automated without humans in the loop?
With great risk, right? I mean, I think that there are certain, as Nate mentioned, like low risk automations that can happen maybe without a human constantly in the loop there. But you know, with everything, there has to be a balance of, you know, convenience and automation versus risk and value. So certainly not right out of the gate. I wouldn't recommend having humans out of the loop in these scenarios. And certainly for automated optimization where the stakes are high, the changes are potentially, you know, breaking if done wrong. Definitely recommend having a human in the loop to at least do like the cursory PR review and approvals, to understand like what the goals of that automated action are, and to measure that you're achieving those goals without negative trade-offs. Once these automations have been running for a period of time, they become very predictable. You can start to probably remove humans from the loop in some of those scenarios. But, you know, I would definitely flash a caution sign for getting people entirely out of that workflow.
Yeah, and a good rule of thumb I've seen with my customers is no automation in prod. So if you want to do right sizing automation, definitely try it out or keep it in a lower tier environment, so like a dev or test or QA environment, because what I've seen historically is there is most of the cost savings are actually to be found in those environments, because, you know, engineers are looking at prod more closely. So typically in terms of cost saving measures, there's a lot to be had in dev, test, non-prod in general.
Great. The last question we had is, are there any AI for FinOps features on the roadmap?
Yeah, there's actually a number of AI for FinOps features on the roadmap. And to be clear, AI for FinOps, FinOps for AI. What the question here is asking is, are there going to be AI powered or AI tools inside of Kubecost that will help developers and FinOps practitioners do more, do it faster, or do it in an automated fashion? And yeah, everything from being able to ask questions of Kubecost using natural language through to using AI to look at very large data sets and identify things like anomalies. We have some of these capabilities already, and many more are on the roadmap, and you should be able to see those coming to fruition over the coming number of months. And we'll certainly be providing release updates and notes of those important features as they become available to customers.
Great, thanks, Joe. And if you all have any other questions that you think of after this webinar, you're always welcome to email us. And our email is team-kubecost@ibm.com. So feel free to reach out to us there, and we're more than happy to kind of dig into any specific use cases or problems you're trying to work through. And also we wanted to flag that, you know, your feedback matters. We want to hear from you, the good and the bad, so that we can help kind of guide the product roadmap. So feel free to, you know, leave us a review on Gartner Peer Insights if you have time. There is a QR code there where you can scan that to go leave us a review. And if you complete one, then you'll actually get a gift card. So please help us out. You know, the product feedback helps drive our roadmap. So we'd love to hear from you. And just as a reminder, I will be sending an email of this recording out to you all within the next day or two. But with that, thank you to both our speakers, Joe and Nate, and thank you all for joining today, and we will see you next time.